Hello and welcome back. Uh, so, what are we doing today? We are doing Tetris. And the goal for today is to get the collision detection to now work with our new rotation system. I know it's broken and busted. We will get to that. But I would like to get... I would like to, kind of keep continuing forward. We will fix those bugs. We will get it working. But at the moment, why is that like crunched over? Okay. But at the moment, I'd like to build in or upgrade the collision detection that already exists to now take the new rotations as well. And I'd probably rename this to rotate instead of rotate right, but we will get to that. We don't need to rotate left. And we do, let's see, collide. Here's our big function. Okay. So, with our collide method, we're passing in the board, the x difference, and the y difference, and then we're detecting does that go out of bounds. So, position x plus the difference. So I'm wondering, I can't remember. Is this the new x and the new y, and then it just determines? I think it is. It's the new x and the new y. Alright, so we'll rename it because it's going to become confusing. So I know that I said it was the x difference, but we're adding our position to the... Oh, am I also... Yep, I am. Okay, and then we'll call this new y. And we'll copy that in. Okay, so we have our new x and our new y and our board. So we really can just pass in the the rotation coordinates to it. So we don't actually want to rotate just yet. We want to detect if we want to detect if this is going to work. So, good method for this. A good way to handle this is, no, this is a x difference. Maybe it was... This is what happens when you pick back up on your code like 3-4 days later. Okay, so if we have collide board and then we take... Crap, so it is the difference. Okay. Because we take the current position. Okay. Okay, so I think we're gonna have to we're gonna refactor. So I will rename these back to xdiff because that was a descriptive name and I just blatantly ignored it. And we're gonna create another one, self dot, and at the moment I'm just gonna call it something different so that we can test it. So we know we want to take in the board, and I want the new x and the new y. And then basically this is going to be one cell. So if new x. Well, really, I can pass in the coordinate, right? So if the coordinate dot x plus the self dot position dot x is less than board bounds min x, return true. And so I guess it is essentially going to look the same. Except it's doing these comparisons of max x and max y. And we really don't see, this is doing the entire shape, whereas, or I want it to be each individual cell. So it's pretty much the same. Chord y plus self position y is less than board bounds min y, then return true. And then if chord x plus self position x is less than board, or sorry, greater than, so this is where it is different, board bounds min max x, then return true. And if the chord y plus self position y is greater than board bounds max y, return true. Else return false. Okay, so it's almost the same, except it's this is dealing with the entire shape, and this is dealing with each individual coordinate. So what I'd like to do is actually do each individual coordinate. So I'm going to switch these from using this kind of collision to the other kind of collision, and then we only have one collision method. Because what I would like to do is start planning and figuring out, and I'll probably, let's see if we can fit it in this episode, and we are going to see if we encounter another block as well. So that's another type of collision detection that we obviously are going to need. Okay, so we want to, okay, so we're going to try to use the new one. So if, so it's not an if, what if we did collision detection based on a shape? Well, we're doing well, okay, let me think about this, because we're doing rotate right, we're doing a for each coordinate, and then we're actually performing the action. Whereas we really want to be doing a fake one, and then we'll set it if that's if that is in fact what we want. So var new coordinates equals an empty array at the moment, and then each time we do this, instead of passing the result into the chord like this, we're going to create the exact same object. So the object has to have the same signature in order to work correctly. What we're going to do is we're going to have it switch out. So we'll say new coordinates push x or result x and y result y. Okay, and then we can remove these. And if this doesn't make sense just yet, hold on. So what we're trying to do is we're going to rotate, and we're not actually going to rotate. So we're going to do all the math, all the calculations that's required for the rotation, and then we're going to push them onto this coordinates object. The coordinates object has the same signature, so it has an x and a y, just like our real coordinate object, which is in shape. Shape. It's probably time we move these to separate files, but yeah, we have coordinates, right? And coordinates is nothing but an array of objects with x and y, x and y, x and y, x and y. So it has the exact same signature. So what we're going to do is we will create this mocked out set, this new coordinates. Then we will run it through our collision detection. So we will do and we're going to need what I call a good to go. So I don't know if you've seen this in any of my other videos. I can't remember if I've done one or if I did it in this one maybe. So I always call it GTG, and it just kind of tells me like, oh, that's what I'm doing. And it's this pattern that I have of I set a flag to true, and then then you can do any sort of looping logic, and if it gets set false at any point, well, there's two ways to do this. So you can, well, not this method, but there's two ways to do this kind of logic where you loop through something, and one is the immediate fail. So if you loop through like 10 things and you have some criteria, so like let's say that x is greater than 3. So if x is greater than 3, that's bad. So if you're looping through all these things and the third one is 4 or has an x of 4 or something like that, then you do return false and you come right out of the loop and you quit. And that's an immediate failure. This model does a non-immediate failure, or whatever we should call it. And basically it allows all of them to go through, and then at the end goes, okay, did any of you not work? And then that's that works. And I think I'm wondering if the all method of arrays works the same way. I don't think so. I think it quits out. So if we go to array MDN and we look at the all method, so array.all, is there not an all? Oh, every. It's called every in this language. So we check out every. Come on. Okay. Then the every method executes the provided callback function once for each element present in the array until it finds one where the callback returns a falsy value, such as an element is found. The every method immediately returns false. Otherwise, the callback is returned true for all elements. Okay. So that's not what we want. We don't want it to do everyone. So let me see. A sum method tests whether an element array passes the test implemented by the function. Cool. Sum executes the callback function once for each element present in the array until it finds one where a callback returns a true value. If such an element is found, sum immediately returns true. So that's also not what we want. I think I was looking for this the other day, and there was just no method that kind of implements this, and it's something that I've wanted in like all of the languages that I deal with, and I just haven't really found a good method. So I always fall back to this good to go. So yeah, I'll explain it. So now what we can do is we'll start implementing it, and we'll do self.shape, or no, we want to do the new coordinates now. So new coordinates dot we will do self.collide, the new one, and pass in the board. And the new coordinates, yeah, we could do that. We could pass in an array of coordinates for this, and then we put the for each in here instead of having to do the for each everywhere else. So we'll call this coordinates, and then we'll do coordinates dot for each function. All right, and then so in here we're going to implement our good to go. So var gtg equals true, and then if any of this, so instead of returning, which is an immediate fail, we want to do gtg equals false. So that means, oh, it broke. So if we paste that in here and here and here, and then we don't need this because it'll fall out the bottom, and if none of these match, then it's still good. And my IDE made that look a little more ugly. And I'd spend all day trying to fix this, so we will just leave it. Okay, so we have our collide function, right? And when we have var good to go, we'll call it collision. And true will be there was a collision. False will be no. Because we want this to also kind of read like English. So if not collision, then it's good to go. So I guess we could flip the, yeah, we'll flip these flags and we'll set these to true over here. Yeah, so if self.collision, then don't do it. If not self.collision, then do it. So that's the method that we're, kind of the behavior and functionality that we're going for. Okay, so then we'll just return GTG in whatever state it is. And so remember that as this thing is looping through, and I forgot my, there we go. As this thing is looping through, if it encounters one of these, it'll set the flag to true, right? And then, you know, it'll just keep on going. It'll keep on testing. Which, oh, well, now that I think about it, we kind of, it's okay to have an immediate failure, right? Because we don't need to, like, let everything go through. So we could just do all then. So array dot, or not all, every. Function. So then we can switch these back to return false. Man, I'm going back and forth on this, aren't I? Well, what I'm looking for is I'm looking for the best way to do this. And sometimes it's not the most obvious at first, and then as you start plugging through it, you go, oh, it'd be so much better this way. And hopefully it doesn't take you long to switch your code to that. And so then we can say return that. So if every coordinate in here returns true, then it's good. If any of them return false, then we have a big problem. Okay, good. This is looking good. So our collision has now been reduced to one method, or one, pretty much one function here. So okay, so now we have our collision, and really in order to implement it in all of these, we're going to have to do a little bit more work. So we'll do if Okay, so what I'm seeing here is we need to take each of the cells. Well, but position. But this is dealing with the block's position and not the. These are. Max, min, shape, max, min. See, what I'm thinking is we might actually want to switch some of this as well. Because we're doing all of our drawing based off of the coordinates plus the position. Right, so we do need the position. Okay. Okay, so movement needs to be based on position. Okay, and what's going on here? We take the position. Here we're detecting position, and here we're detecting each cell. Collision detection could still be done with each cell, but then we'd also have to pass in the position X and the position Y, which wouldn't be that bad. Okay, so we have our coordinates, position. Maybe we should do that. So we'll say X and Y, or we could just pass in the position. Yeah, so position and then coordinates. So what I'm trying to do is not have two collision methods, because if you can encapsulate it all into one, then you're not having to worry about these two different ones. So we'll say, so now we can drop this. Oh, and it makes it easier to unit test too, so that can be very helpful. Okay, so now this collision detection takes a position and then coordinates of each, or the coordinates of the shape. Okay, so now what we can do is we can say if self.collide board and we can pass in an object that's self dot, well, x and y being self dot position y minus 1, because we're decrementing the position down here. That's our position, and then we can go self dot shape dot coordinates, and we can switch to collision. So if self dot collision, return false. If a collision was detected, right? If collision detected, return false. If it's not detected, perform the move and then return true. Okay, I think we've got the pattern. I think this is what we want. So it's the method's looking a little longer. We're passing like more things into it, but again, I think this sometimes it's worth it to get things kind of the way we in I don't know, good functions that are descriptive and are multi-use, so that we don't have 3 different ways to do the same thing. So finding a common pattern, it's kind of like you're in math class and they're talking about find the common denominator. It's kind of what we're doing, just programmatically, logically finding the common denominator versus mathematically finding the common denominator. Okay, self position x minus 1, and then y self position y, and then self shape coordinates. Cool. Okay, good, good, good. That's good. We're doing good here. Here we're building coordinates. Then we want to check our collision. Over here, collision. We don't need the good to go flag, so we decided against that. And here we're going to pass in pretty much the same. Well, now we can just say self.position because that's the object we need. We needed to do this instead because we actually had to alter each one of these, but we don't need it down here because we're using it exactly as it is. It's in the same position, we're just rotating it, so we need new coordinates for the shape. Okay, now our collision detection works. Now we can remove our collide function. Well, it should work, hopefully. And what we're going to do to test that is there's, I didn't do the last step. So here we're checking the collision. So if self.collision, then return false. And else, then we're going to say self.shape coordinates equals the new coordinates. Okay, there we go. Now it will actually perform the rotation, hopefully. Oh, okay. So we are going to test this out. Press N, move a block down, and press up to rotate it. We are still rotating. It's still kind of funky. All right, and now the goal is I'm going to move it somewhere where it might collide. Okay, so we're going to move it over, and this should work, and then this should work, and then this should not. But it did. So there is an issue with our collision detection. And we're getting a bunch of errors because obviously you can't find that. Yeah, so we are hitting some issues. So we need to flip over and figure out what did not work in our collision detection. And probably the best way to do that is to debug it. So we will go to self.collision, coordinate x, position x. Okay. None of these are applicable. So self, no, we want board. We don't need board. Well, kind of. Board.bounds.min. And does it display nicely? Kind of, not really. Okay. Board bounds min x. Board bounds min y. Board bounds max x. And board bounds max y. 9 and 9, yeah, that makes sense. And then we need coord x and coordinate y and our position x and position y. Okay, so now we need to rotate. Rotate. We hit our collision detection. So then we're saying here if this particular coordinate is x and y of 0 and 0, right? And then add that to the position, which I'd like to see. So we'll say coord.x plus position x is 0, and coord x y plus position y. And then we could even like put in this whole function and just determine that as well. So, well, this one we're not colliding. So with this rotation. So this may not be a very good example. We need to find one where we will in fact collide. And just making sure we're hitting that when we move, which we are. I'm going to rotate up, and we're going to slide it over, and place another breakpoint, and we're going to rotate, which should throw one of the blocks off the screen, or try to, and figure out if our collision detection actually is working, or if there's something else going on. So we've got 16 and 1, that's within the bounds. Then we have, oh, well, why aren't we hitting that? So that's a really good question, because I thought that, because none of these return false. Oh, it returned undefined, which is determined to be false by JavaScript. Okay, so I needed to, in the bottom of this, return true. I thought it would just kind of ignore that and be okay. So press N, get a block on the page. Of course, we're going to be running into this the whole time. Move. Oh, I can't move. Can't move to the right. Okay, that's weird. Refresh. Put a breakpoint on. Press N. Move to the right. And our position X is 118. Max is 19. Nope, that's not what I wanted. I wanted this. Okay, so we're going to the next one. 218. 318. 418. Come out of the function. So if self.collision return false. Oh, it's returning odd. Okay, what did I mess up? So I messed up here. Okay, if, what is this? Collision returns collision returns true. Okay, we need to figure out what this is returning. So we're going to do var test equals that, and then we'll just at the very bottom we'll return test. So everything's linked back together. Oops. And then we can reload the page, come down, models, and we'll place a breakpoint at return test. And press N, move to the right, and we get test equals true. So if, okay, so if not, okay, I guess that's starting to make sense. So we need to return not coordinates. So the inverse of what it returns. Okay, refresh the page. Press N, move to the right, remove the breakpoint, moves to the right, move to the right again. Good, 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 and good. Good, okay, and good. All right, so now we rotate. That's fine, and it's not letting me rotate. Good. Move to the right. Now we do rotate. Try to rotate. Won't let me. Need to come down a little. And it does rotate. Okay, so we have working collision detection for a board, or for a working collision detection for our blocks, whether it's rotating or it's moving. So we're almost there. The last thing that needs to be patched in is when it actually collides with either another block or with the blocks that have already been completed down at the bottom of the board, which we are getting to soon. We will be able to start playing the base versions of this game very soon. So the next thing I want to do is actually that. So the next episode, I don't like to make promises in the future, but here we go. Next episode, I will be having the blocks come down and actually kind of save down here. And then we can add a new block in and start moving that one down, and then add a new block in and start moving that down. So a little bit of work that's going to need to go into that, obviously, but we're making good progress. Sometimes things aren't as straightforward. I thought this was going to be pretty simple. I was like, oh yeah, it's, rotational collision detection. It's going to be trivial, and it took me quite a while. So I'm looking forward to it, and I will see you guys next time.